Let's go ahead and start the event. Get all fancy. Alrighty, and send a ping in the Academy chat at Academy. We're getting started. Workshop number 6. Woo-hoo. Cool. All right, so welcome everybody. Hey, Generous Kid. Hey, WER. As always, we're gonna wait until a couple minutes after to give people time to roll in here, and I'm just setting up while we wait, so you can watch me set up. Watch the genius at work, of course. Audio is breaking. Is it only me? Just you? Oh, okay. I'm glad it's not me. Get enough sleep? Unfortunately I didn't SSE, but here we are, right? And it's another day. Beautiful Emerald Academy Friday morning. Let's rock and roll, baby. Does anyone like Harry Styles and or listen to Harry Styles? Here and there. Yeah, well, he came out with a new album literally last night, and I've been listening to it on repeat over and over again. I think it's awesome. I also just realized I definitely should have saved some of our progress from the other day. This is kind of bad. I'll try and do this really. Okay. Fridays are great for new music. Oh yeah, totally. Yeah, you should listen to the new Harry Styles album. It's awesome. I'm a big fan. All right, we'll wait like 3 or 4 more minutes just to give people time to roll in, and yeah, for everyone that's new that's still rolling in, I'm just yeah, I'm currently just setting up for our lesson today. Okay, this should be fine, I think. Okay. What's up, Ricardo? How's it going? We got Q in the house. Hey, Q. Numini, back at it. Davon, what's up? Hey, Bread. Did everyone participate in the giveaway? That giveaway got a lot of attention. That was awesome. I think we got a crazy amount of actually attention on that. Let's go to that really quick. Yeah, I think we got like, oh my god, wow, we got like 700 likes and 600 retweets. That's crazy. Wow. Yeah, for anyone that didn't see, like an hour ago, we announced that we actually updated the Emerald ID site. So, this was developed by yours truly. So this was I'm, for the record, really bad at front end development, but just recently I started learning how to do it. I don't think it looks too bad, right? So if anyone has any suggestions, let me know. If you think it's terrible, also let me know. And you're also banned. It's terrible, and he's banned. All right. Get started in like 1 more minute. It's banned. All right. So we get started. Let's go for it. All right. So welcome everybody to workshop number 6. Wow. It feels like time's flying by. I don't know if it's just me, but anyone else feel like it's just this boot camp's just flying by? So yeah, workshop number 6 is our third to last one, and today marks a pretty special day because we've gone through all the most complicated stuff. Yay. So from here on out, we're pretty much just going to be applying everything you've learned to make our own NFT contract. So the next 3 workshops that we have left are pretty much just going to be dedicated to make our own NFT contract. So you've learned most of the concepts you'll need already. So congratulations to all of you, and big thumbs up for making it this far. So yeah, let's just get started. So to sort of recap what we did in the last workshop, remember we had a resource NFT. It had an ID, it had a name in it. We talked about sort of the benefits of UUID, right? And we set the name for the NFT and all that fun jazz. And then we, had a function to create it, right? Because you can only create resources in the contract. This is pretty simple. You all know this already. And then in our transaction, I'm going to rename this to like mint NFT. In our transaction, we had a bunch of stuff, like we were linking it so we could read it in a transaction or in a script and all that stuff. But for now, just remember that, we stored the NFTs in our storage, right? So let's go ahead and walk through this, just for a second here. So I'm going to pick a random name in the chat. I see June. So, or is it June or Jun? I don't know how to pronounce that. Sorry if I'm not pronouncing it right, but we'll do Jun. And let's do it for account 1, right? So if we go ahead and send this transaction, what's going to happen? Well, it's going to say account OX01 is updated to storage. So, yay, we stored an NFT. Now, remember, during the last workshop, we discovered that one of the problems with doing this is that if you try and store it again, right, what's going to happen? Well, it's gonna complain. And the reason it's going to complain is because we mentioned that you can only ever store one resource at a path at a time, right? So if we try to store this again, it's going to give us an error. Well, actually, we figured out that the playground doesn't give us an error, just straight up crashes. So we're not going to try that again. But you get the point that we can't store it again. Now, there's 2 solutions to this. One solution is to, specify another path, right? So we could just specify my NFT 2, and then we could store another NFT there if we wanted to. But we discussed why that wasn't the best. And you can read more about that in Chapter 4, Day 3, about why that's not optimal. But the reason is that makes discoverability really difficult. Because now, for every single, resource that you want to show to the public, you have to give them a different path to look at. And that's really difficult for applications because applications usually only know one main pathway to look at to see all your NFTs. So, for example, when you're on the float site, we use one path to see all your floats. So if you had any floats at a different path, we wouldn't be able to see them or we wouldn't display them on the page. So does anyone have any ideas? And this is sort of going to be the topic for today. So it's kind of already hinted in the title. But does anyone have any ideas for how else we can solve this multiple NFT problem? Feel free to type it in the chat. And hint, hint, we also mentioned it during the last workshop too. Yeah, Q, exactly. So you mentioned a container last time. Yep. So very close. I'm looking for a specific word. Throwing them in a dictionary should solve it? Exactly, Ricardo. So storing them in a dictionary should solve it. And where should that dictionary be? Inside of what? Yep, exactly, Bravestar, a collection. So that's what we're going to focus on today, is a NFT collection. And so what we're going to do is, just like Ricardo said, and, Q was sort of, brushing upon, is we're going to put a dictionary inside of a resource called collection. Then we're going to store the collection at this path, name it something like my collection, and then we'll be able to store all of our NFTs at that one path, which is perfect because then applications that are reading our storage or reading our public paths will be able to go to one location that they know it exists at and read everything. So that's going to be the topic for today, is collections. All right. So let's go ahead and implement that. So let's make a public resource called collection. All right. And for the record, we're pretty much just going to be implementing, what is it? This right here. So all the code's pretty much right here if you just want to copy and paste it. But we're going to walk through all this together anyway. So we're going to make a public resource collection. And then inside of this collection, we're going to have, let me mute that. We're going to have a dictionary of resources. So just like, Ricardo said. So we're going to name this owned NFTs. And by the way, you may be asking why I'm naming. Oh, sorry, public var. I don't know why I said resource, but also you may be asking why I'm naming these things, certain things. This is actually going to be important to name this exactly like this, and I'll tell you why in a later workshop. But for now, just trust me and make sure you're naming things the same that I am. So this is going to be a mapping between, it's a resource mapping between an ID and then the actual resource. So remember, back a couple workshops ago, when you have a dictionary of resources, you put the symbol out front, then, we're mapping the ID of the NFT to the NFT itself. So the key is the ID of the NFT, and then the value is the NFT itself. Okay? Awesome. So as with any, with anything, we have to make sure we initialize this. Oops. And we're going to say self.ownedNFTs, the arrow, and then this notation. So here's an interesting thing that we haven't talked about yet. Missing destructor for resource field owned NFTs in type babyjacob.collection. Oh, okay. Before we move on, by the way. So every single bootcamp, I allow everyone to decide what we want our NFTs to be called. In the last bootcamp during the month of April, we came up with Baby Jacob. So that was what everyone decided. So one of your tasks right now is all of you have to come up with a name for our NFTs. And whichever one gets the most votes wins. So Bravestar wants Get Wrecked. Bam wants Pink Hat Kid. God. So you have to vote with your thumbs up too. And also, just please. Oh, Jacob ban list. Okay. Oh, hey, Kim. It's great to have you here. Yeah, so whichever one gets the most thumbs up, that'll be the name of our collection. And I'm begging you, please don't make it that long because we have to type it out every time we have a type. So it looks like it looks like Kim's is getting the most votes. How do you say that? Busy Bees? Is that it? Like Busy Bees? Or BZBs? Okay, so Busy Bees. Okay. So is that the answer? Are we all going with Busy Bees? All right. Looks like that's it. So round of applause to Kim for the answer. All right, so this is going to be the name of our NFTs for the rest of the boot camp. So Kim, you've done a fantastic job. That's going to be it. All right, so let's just go with it. So yeah. So anyway, so it says missing destructor for resource field owned NFTs in type busybees.collection. So why is it saying this? Well, this is something we haven't talked about yet, but when you have resources inside of another resource, you have to explicitly destroy them. So what do I mean by that? Well, when you when you mint an NFT, right? Like when we create this NFT, I told you that if you want to destroy it, you do like destroy and then like the variable, right? So something like that, or like my NFT, right? So that's how you destroy something. And that's because there's an implicit destroy function in every single resource by default. So just like UUID, there's actually a hidden destroy function right here that you're not seeing, but it already exists for you. But the idea with resources inside of other resources, or they're called nested resources, is you have to make sure to define the destroy function by yourself. So you actually have to put destroy here, and then inside of this you put destroy self.owned NFTs. So what this will do is when this resource collection gets destroyed. So if we were to write something like destroy my collection, it will run this destroy function and then also destroy all the resources inside of it. Now, the reason for this is just because, remember we talked about in Cadence, you have to be really specific about, where what you do with your resources. So Cadence really wants to, for you to be aware that when this gets destroyed, all these will get destroyed as well. So that's why we have to define that ourselves. And I usually put destroy after init. So I'm just going to leave it after the init. Okay, but it doesn't really matter. All right. So boom, that we have this collection now. That's amazing. So one more thing we're going to do before we start testing this code out is we're going to define a deposit function, right? Because why would this be exciting if we couldn't actually put NFTs into our dictionary, right? So we're going to deposit a token, we're going to call it, which is going to be a resource type. And so what we're going to do is we're going to say self.ownedNFTs, and we're going to force move the token into the dictionary at the token.id. Right? So super simple. And you'll notice that, this isn't a new concept for all of you guys. This is coming directly from the chapter where we talked about adding and removing resources to dictionaries. So this should be pretty familiar to all of you. And I believe that's what we have. Yeah, that's what we have right here as well. Awesome. Cool. So how are we doing so far? I'm going to put a little thumbs up in the chat. And if everyone's doing all right, make sure to thumbs that up. And if you're not doing all right, make sure to thumbs that down. Again, there's never any shame in thumb down. I was confused at 1.2. Of course, now I'm not. I'm a genius, obviously, now, and much better than all of you combined. God, getting to teach the course is fantastic, isn't it? Also, have all of you been enjoying my little notes in the GitHub? I leave some jokes in there here from time to time. Actually, I think in this one, didn't I leave a Thanos meme? Yeah, I did. Wow, look at that. Oh my God, I'm such a fantastic instructor. I sometimes blow myself away. All right. Anyway, back to the boot camp. All right. So now we have the ability to have a collection and to deposit into it. All right. So let's go back. Let's make a new transaction, and we're gonna make a new transaction because we need to make a setup collection transaction. So, in order to actually store NFTs inside of a collection, we need a collection, right? Like that's pretty self-explanatory that we need one of these in order to actually, to do this. So let's go ahead and set up a collection by copy and pasting this. And I don't like the order. I don't like that it doesn't let me reorder this because setup collection should be first, but that's all right. So let's go ahead and do, yeah, so let's do this. So let's say, what is it? Busy Bees. Oh, I have to redeploy the contract. Hold on. Redeploy. All right. So we deployed it. Oh, what did I forget to do, by the way? How are we going to get this collection into a transaction? We can't, right? Because we didn't define a creator. So let's do public function create empty collection. And we're going to return a collection resource. Oops. And we're going to say return create create collection. Awesome. So Raven says just recreate transactions with proper name. Yeah, you're right. Exactly. Yeah. Okay, so we'll redeploy this, and now we should be good to go. And now we can actually get a collection inside our transaction. So let's go to setup collection. Let's import Busy Bees. Thanks, Kim, once again for the creativity. And this is now going to haunt me for the rest of the boot camp. So busybees.create empty collection. Yay, boom. And we're going to store this at /storage/my collection. I don't know. Let's just call it my collection. Okay. Awesome. So now that we did that, we should be good to go. And yeah, so let's just do that really quickly. Okay, so let's I don't know why we don't need this name here. Okay. And in this execute, we're just going to log we saved a collection to our store. All right. So let's had to mute that. All right, so let's go ahead and save that. And boom, it says we saved the collection to our storage. Awesome. So we set it up for our account 1. Perfect. So now let's go ahead into the Mint NFT transaction. Let's import Busy Bees. And what we're going to do is we're not going to have this anymore, right? Because we're not storing our NFTs directly in storage. We're storing them in our collection. So how do we do that? Well, now that our collection exists in our storage, does anyone have any ideas? You can type it in the chat. Please do. How do we actually get a reference to our collection so that we can deposit to it? How are we going to be able to call this deposit function? Borrow it. Nice, Ricardo. Nice, Q. Nice. Love it. Great job. Let's borrow it, right? So Ricardo says, you need to link it first. Great question. So the reason we don't have to link it right now is because we're not using capabilities. We're simply borrowing directly from storage. And we're allowed to do that because we have the auth account. So when you think of capabilities, think of that when the public needs to have access to it in a script. But right now we're just borrowing directly from storage. Exactly. Yep. Okay, so let's do it. Let my collection ref equals account dot borrow from /storage / my collection. And the type of this, of course, is a reference, like you said, to BCBs.collection. All right. Amazing. And then we're going to say my collection ref dot deposit. Oh, okay. Well, we're getting an error. And that error is because we have to make sure to panic if this doesn't exist so that we unwrap the optional. Not exist. Okay. Cool. And now we can go ahead and say my collection ref dot deposit. Boom. And then the token we're going to pass in is busybees dot create NFT. Nice. So everyone see how that works? So we're borrowing. Let's move this for a second. We're borrowing a reference to busybees.collection, from this storage path. And we're panicking just to unwrap the optional if it doesn't exist. Then we can call deposit on that collection, right? And we're going to pass in a token, and we're just passing in an NFT so that we're creating from the thing. And right now you're probably saying, Jacob, well, why is everyone able to create an NFT? And I hear you. We're going to fix that later so only the admin can mint it, but we'll do that at a different time. So yes, awesome. Okay. So cool. And also, some of you may be wondering, why do I put panic on a different line here? This is usually common, how people usually write these things. You could put this on the same line, but, in a lot of times when you're coding, you don't want all your code to be on one line because it's hard to read. So you can separate it, and that's totally okay. And I usually just indent it right there for readability, exactly. And I'm glad you brought that up, Raven, because as we mentioned in the first workshop, readability is a huge, aspect of Cadence. Yep, exactly. Love that. All right. So let's go ahead and in the execute, we're going to put log. We deposited an NFT to our collection. Okay. Sweet. So let's go ahead and put a name. I don't know. We'll put Kim, and we're going to deposit that to our collection. Boom. We deposit an NFT to our collection. So anyone have any guesses? What's going to happen if we try and do this with account 2? And let's put like Q here, for example. What's going to happen if we try and do this? What is it going to print in this console? Exactly. There's no collection for 2. So, exactly, it's going to be an error. And more specifically, it's going to print this message right here. So, this is a really important point that I want to take a step back and talk about for a second. So, you know how, like, on Flow, in all these NFT projects, they always say to you, oh, please make sure to set up your collection. Or, please make sure to set up your collection in Blockdo, right? Why are they saying that to you? Well, it's exactly for this reason. It's because you need to have a collection resource in your account in order to receive their NFTs, right? You can't receive Go-to-Goats NFTs if you don't have a Go-to-Goats collection. So I hope that this bootcamp is teaching you not only about, making these Cadence things, but why these projects are doing things the way that they do them. So I think it's pretty cool that all of you have come to a place where you're able to understand that now. So isn't that awesome? And this is both good and bad. It's good because it's easy. It's easy to sort of understand, and it's great because users or accounts have true ownership of their NFTs. Right? When I have my own collection, I truly do own those NFTs, unlike in Ethereum where it's just stored in the contract. But a bad part about this is that it requires users to set up their account manually for every single project, and that's kind of a pain in the butt. But there's ways of doing this that makes it easier. And one example of that is on Float, for example. We automatically set up the collection for you when you claim your first float. So that's one way of doing it where it's actually really nice because you don't have to manually set up ahead of time. We shove this code into the transaction when you claim your first one. So yeah, just thought I'd point that out. Okay, cool. So we deposit it, but problem. There's no way to actually understand what NFTs exist, right? How do we actually read? We can't do that right now. So we need to actually make a function. Can you replace the panic with a create collection then? So Yes, you could. So, but that's kind of a yes. The answer is yes, Ricardo. But the problem is that like this is sort of like a bad use case. Because in the real world, like when someone wants to transfer you an NFT, you can't set up the collection then because that person didn't sign the transaction. You did, right, as the transferer. Um, exactly, SSE. So that's exactly the problem. So one of the problems that these projects usually have is they can't airdrop people NFTs on the first go round, because the user has to previously sign a transaction to set up their account, right? And you can't do that for them if they don't if they don't have the auth account here. Yep, exactly. So I'm so glad you guys are understanding that now. That's awesome. All right, so let's go ahead and make sure to add a new function here called public function get IDs. Okay, and what this is going to do is return an array of UN64s, which is all the keys of this dictionary. So we're going to return self.ownednfts.keys. So pretty simple, right? It's just going to allow us to return an array of all the different NFTs that we have. So let's go ahead and deploy this. Boom, and now we can read some of our NFTs. So Enjai says, I think you don't need to claim your first, just need to create a collection. You have to claim your... Oh yeah. So it could be, you could do either, Enjai. Because in both steps it's creating the collection for you. So you could do either one. Yep. Okay. Cool. So because we just redeployed the contract, all of our state got reset. So let's make sure to reset up all of our accounts. So let's set up account 1. Perfect. And then let's also mint an NFT. Called Q to account 1. And send. Oh, oops, wait, did I mess up? I think I accidentally did account 2 before. Yeah, okay, I did. So apparently I set up account 2. Okay. So cool. So now let's go to a script and let's try and read these IDs. So import keys from account 1, and we're going to return an array of UN64s. So let's just return an empty array to get rid of that error. And let's try and access the getIDs function of someone's collection. So before we do that, well, there's a problem. How are we going to do that? How do we have access to someone's collection? Uh-oh. Borrow. So how are we going to borrow, though? We have to do something first. And it's going to be right here. When we create the collection, what should we do with the collection to make sure the public can do it? Yeah, Ricardo. So we need to link it. Exactly. Good job, Enjai. Good job, everybody. Right after we save. So remember, this saving or this creation of the collection is only going to happen one time. So it also makes sense to just link it in the same transaction because it's going to be really easy just to set it up all up in one go. So let's do /public/my_collection, and the target is going to be /storage/my_collection, and the type is going to be a reference to BCB's.collection. All right. So let's go ahead and just use account 1 now. We never set up account 1, so this should work totally fine. Let's set up account 1. Okay. Oh, God. Oh, no. Oh, the playground shenanigans have begun. Oh, no. The playground shenanigans are upon us. So let's go ahead and run this, please. Oh, my God. Oh, no. Oh, no. Well, playground shenanigans are back and better than ever.
This is recorded, right?
Yeah, this is recorded.
Cool. I'll send the recording to the playground team.
Playground team, you suck. I'm just kidding. But yeah, this is sort of a bad situation because we can't even. I think we just have to deploy a whole new thing. Okay. Q says, do cadence developers use the playground in production environment? No. I only use cadence to teach, but no. I use the VS Code extension, but it's too much to have all you set up. So So what's the best scenario? I think the best scenario is just to deploy this to a second account. I think this should work. So I think if we switch this to 2, and then if we change this to... Yes. Okay. Nice. Okay. So that worked. So let's go to mint NFT, change this to 2. All right. And let's mint Andrea to account 1. So let's mint it. Boom, minted. Awesome. Worked. Okay. Let's go to our script, and we're going to rename this to get IDs. So you know what we're working with. And then in here, now there's a link to that address, so we can properly link it. So let's pass in an address here. And say, let, collection, or let's just say let public collection equals get account of the address, right? So we have to get the public account first. Then we can get a capability to, let's move down, to /public/my collection. And then we borrow it after. So there's many different steps, but then we borrow. Okay. And the type that we're going to borrow is a reference to BCBs.collection. And then we have to panic if it doesn't exist. So this collection is not publicly available through a link. Okay, nice. Then after we get this collection, we should theoretically be able to return public collection.getIDs. All right. So let's type this in for address 1. And okay. Oh, bye, Kim. Thanks for coming. So is it supposed to be 2? What did I do wrong? Is it my collection? I guess let's... Oh, it already exists for this. Oh, you mean the import? Yes, thank you, Numini, thank you. So let's try it again. Woohoo! It worked! Yay! So look at it. So it's returning that we have a NFT with a value 3 instead of our collection. So super awesome, right? We did it. We successfully deposited an NFT to our collection, and then when we asked for the IDs, it said there's an NFT with ID 3 that maps to an NFT. Yeah, there's an ID 3 that maps to an NFT with ID 3. Nice. We've done it. Super awesome. So the next step is to declare a withdrawal function. And that way we can withdraw NFTs if we want to. So let's go ahead and declare a withdrawal function. We're going to ask for a withdraw ID. Oh, actually, before I keep going, I want to make sure everyone's okay. So let's thumbs that up if you're doing all right. In the text channel, we have some Andreas. So if you're also good, make sure to Andrea that. So we have a thumbs down from Raven. So Raven, what can I help you with? Only I can help myself. All right, well, I'm glad you're doing all right. Good. Okay, so we'll continue from here. So let's go back to our contract, and yeah, so we're going to withdraw AID, and we're gonna withdraw an NFT through its ID, right? So let's go ahead and let's say let NFT that we're gonna withdraw is self.ownednfts.remove at the withdraw ID, right? And then we're going to return the NFT. Now look at it. It says mismatch types. So we need to return a reference or a resource NFT, and it says, wait a minute, there's mismatch types. Expected, NFT got NFT optional, and that's because we forgot on this line. Let me just go back for a second. We need to panic right here if this doesn't exist. So panic. Say, you do not own an NFT with this ID. In fact, we should probably just put this on a new line. All right. Cool. So again, this goes back to that lesson we did on withdrawing from a resource dictionary, and same with this one, positing one. Okay, cool. So let's go ahead and deploy this contract, and all of our state's gonna get reset. So let's just be mindful of that, and let's set up a collection for account 1. Boom. Let's mint an NFT to account 1 with the name of Numini. And then let's read our IDs again from account 1, and we'll notice that again we have a new. Oh, look, we have one with ID 1 now. So cool. So let's see what happens if we define a transaction called withdraw NFT. All right. So inside here, what we're gonna do is we're gonna now take that NFT out of our collection and destroy it, and then try and read the IDs again to see if it changes. So let's do that together. So we're going to do withdraw NFT. So I'm just copy and pasting some code. And in here, we're going to do a similar thing. So, we can actually keep this code because it's the same exact thing, right? We're just borrowing our collection. And then instead of deposit, we're going to say dot withdraw. And then what's the withdraw ID? So let's just pass that in up here. UN64. Okay. And it said, yeah, so this is going to actually withdraw something out of our collection. So we're going to say let NFT, and then we're just going to destroy NFT because we're just going to get rid of it for now. Okay. So the question now is, well, how do we know what number to type in for our withdraw ID? Well, let's try it. So if we go to, let's try a random one. Let's try 0. Is this going to work? Oh God. And Playground's back. Please. Oh my God. Who came up with the idea of making the state window floating? Oh, this one? I mean, to be honest, it's kind of cool. But I guess maybe it could be improved. Create a new script. Yeah, let's try it. Let's try it. Let's try it together. And I'll try and go slower this time. Okay. So let's go slow. Let's try 0. Okay, perfect. It worked. Great suggestion, Ricardo. Thank you. Oh my God. Delete this one and great suggestion. Awesome. Okay, so we typed in 0 here, and look what it said. You do not own an NFT with this ID. Well, where is this panic coming from? I don't see it in here. The answer is it's coming from our contract, right? Look what we typed in here. Do not own this NFT with this ID. So that's because we typed in an ID that we don't even own, right? But let's go back to our script and let's run this getIDs function again. So what IDs do we own? 1. We have an ID with ID 1. So let's go ahead and withdraw this NFT with ID 1. So send it. And we're going to say we withdrew and destroyed an NFT. Right? Let's send it. And boom, we withdrew and destroyed an NFT to our collection. So if we go back to our script and type in address 1 now and execute, empty array. So we have nothing now. Super, super cool. Woohoo. We did it. So I believe, if I'm not mistaken, is that everything from this one? Oh, no. Okay. Yeah, we actually have more to do. Okay. So, wow. Okay, we actually have to speed through. All right, so I'm just going to say this right now. I apologize to everybody. We're a little bit behind schedule, so I have to kind of race through this next part. So if I'm going too fast for you, please watch the recording because it's easier that way, and we have to get through this stuff. Okay, so there's a problem right now, and the problem is that right now in our setup collection, we're linking our collection to the public. So a big problem with that is now anybody, because the type is busybees.collection, anybody can withdraw from our collection, and that's obviously really bad. So really quickly, anyone have any suggestions for how we can make it so that everyone can't withdraw, but they can deposit, for example? Interface, exactly, Ricardo. So public resource interface, iCollection, and we're gonna put our two. So what do we want inside this interface? Well, we want the deposit function, and we also really want the IDs function, because we don't really care if people deposit or get our IDs, but we do care if they withdraw. So this is what's going to be available to the public, the deposit and get IDs. Yep. So we're going to make sure that we implement iCollection now. All right. And so let's go ahead and deploy this again. Oh my God. I refresh, and otherwise I'll just deploy to a new account. All right, 2, 3. Okay, it worked. Let's go ahead and change all of our things here. Shenanigans strikes again. Yeah, the shenanigans. Okay, so now that we did that, we have to make sure that when we actually link our collection, let's make sure we only link what we want. So we have to link the busybees.i collection, so it's restricted now. So that way, inside of our script, look. So we also have to make sure to change this too, right? Because we're borrowing the wrong type. So busybees.i collection. All right, and so now, of course, we're still able to call get IDs, but we're not able to call like withdraw, right? So this doesn't work because it's not accessible, right? Member of the restricted type is not accessible. Perfect. Did it. So awesome. That's exactly what we wanted. So I believe that concludes this chapter, right? Or this day? Yeah, it does. Okay, perfect. So we have to sort of speed through day 4. So let's do that. Okay, so what's in here? Okay, minting. And then transferring, I think, is it? Okay, cool. Yeah, so remember I mentioned before that one of the problems with this contract right now is anyone can mint an NFT, right? Because this function's public. So how do we make this function not public? We only want the admin to be able to do this. So the way to solve this problem is to say public resource admin and put this function inside of an admin resource. All right? Boom. Inside of an admin resource. So this is great because now only the admin will be able to call this. But now the question becomes, who's the admin? And how do we make sure that, that not everyone can get this admin resource? Well, the answer is we, inside of the init function for the contract, I don't know how we haven't defined this yet, but inside the init function for the contract, you can do stuff in here that's actually really cool. And we haven't talked about this yet, but in the init function of the contract, you can access something called self.account. And what this is this is the auth account of the contract owner. So what we can say is that when we deploy this contract, we want to save an admin resource to our deploying account. And so that way, we don't even have to make a public function admin, for example, or create admin, right? Because then anyone would be able to call it. So instead, I don't know why I typed that. I meant like create admin. But instead, we're going to just create it inside the init function of the contract. So self.account.save create admin to /storage/admin. All right. So now the contract, and this looks weird because it's not in a transaction, but this self.account is referring to account 3. So when this contract gets deployed, boom, now the admin will be able to, create NFTs. So that's awesome. So let's just go ahead and do that. So let's go, and inside our mint NFT, we have to change this now, right? Because it's no longer, we're no longer just accessing the public function. The admin has to sign this transaction. So, so the person signing this transaction must be the admin because they're the only person that can mint an NFT. So here, we can even change this to like admin, right? So let's go ahead and say, let's get rid of some of this stuff. We'll keep some of this for now, but let's just ignore that right now. I see. How will other people get to create NFT? Mint them. So in this example, fodder, the idea is that no one will be able to except the admin. And so this is more of like a real world scenario, right? Like, for example, Goated Goats you don't want everyone to be able to mint goats because then they would just hack the system, right? What we want is the admin to be able to mint them, and then maybe the admin can sell them to people, right? So they can have, they can put them up for sale and stuff like that. But we don't want everyone to mint because then that would be a problem, obviously. But in if you wanted to have an example where anyone can mint, then that's totally fine if you wanted to do that. Yep. So let's go ahead and inside our prepare statement, let's get the reference to an admin. So let's say let admin ref equals admin dot borrow from /storage/admin. Remember, that's where we store it. That's where we stored it. And the type is, BCBs.admin. So when people mint a NFT, how does that work behind the hood? It totally depends on the project, Fodder. Digging the goal left today? Yeah, of course. Yeah, so Fodder, it actually totally depends on the contract or on what project it is. I'm not like I would have to have a specific example usually. So when we claim a float, we also minting it, or is it just transfer? No. So when you claim a float, you're actually calling a public claim function. Yep. But sort of to build upon that, like it's a bit more complicated than that because there's also secret codes and capacity limits and stuff like that. So it's not really a public claim function. It's like a public claim function with restrictions, if that sort of makes sense. Yeah. Okay. So we access the admin here. All right. And so now that we have the admin, well, first let's panic and just make sure that it's actually this, not admin account. Okay. Now that we have the admin, we can create an NFT. So let NFT be admin ref dot create NFT. Okay. And we pass in the name. And now down here, okay, let me just zoom out again. Down here, we don't have access to the recipient anymore, right? Because the recipient, we can't just do like recipient.borrow because the recipient is not the one signing this transaction. It's the admin. Okay. So we have to specify a new parameter here called recipient and a certain address. And then we have to get account, the recipient. Okay. Let's just put all this down here for now. Dot get capability to /public/my collection. All right. Then dot borrow. I know I'm moving so fast, and I hate that I'm moving so fast, but I have to. I'm so sorry. BusyBees dot collection. Restricted to BusyBees dot iCollection. Okay. And then panic. Collection does not exist. And what we can do now is because the deposit function is available even with this interface restriction, we say my collection ref dot deposit NFT. And we're done. All right. So how does that look? The admin signs the transaction, right? The admin mints the NFT because they have the ability to do that. And then they access the public deposit function from the recipient's account. So notice the recipient is not the one signing this anymore. All right. So if we go ahead and type in, well, let's just set up a collection first. Oh, no. Okay. So if we do, let's set up a collection from account, let's just say 1, okay? All right. Now we're going to mint an NFT, but so the contract is deployed to account 3. So in this example, who should be the one signing this transaction? Any guesses? 3. Great job. Great job. I'm so happy you guys are understanding that. Good. So account 3 should be the one signing this because they're the one that have the admin. So the name, let's just call it NJ, and the recipient is account 1 because we set up their account. So let's send it. We deposit an NFT to our collection. Now if we go to our script, let's see. Account 1 have an NFT. They do. Boom. Done. Yes, we did it. Okay. So we just keep going. Oh my god. What else do we have to do? So we did transferring and minting, I believe. Right, we set up the minter. We did the minter, and now we have to borrow. Okay, cool. So The last question we have to answer today is how do we read more than just the IDs of our NFTs, right? Because right now in our collection, the only stuff that we can reason about our NFTs is the IDs. So it's not that interesting because we just know that we have certain IDs in our collection. What if we actually want to read information about those NFTs? We can't right now because we can't access our NFTs that are in this dictionary. So what we have to do is we have to make a function called borrow NFT. And what this is going to do is return a reference to an NFT so we don't have to move it. And that way we can read information on our NFT. So let's go ahead and say, oh, we have to pass in an ID here to read it. So let's say return a reference to self.owned NFTs at the ID. And then, of course, we have to, add the little as thing here as the reference to NFT. All right? Cool. So now in a script, we can call borrow NFT, right? We can call borrow NFT to read stuff like the name and the IDs. So what's one thing I'm forgetting to do? Why can we not really use this right now in a script? Interface. Yep. Perfect. We have to add this to the interface because we want it to be publicly viewable. Great. So we can go ahead and redeploy this. All right, deployed to account 3. Nice. And so let's make this script, we're calling this what? Get IDs, right? So we're gonna make another script called get metadata. Yeah, we'll call this get, because I'm a organization freak. I'm gonna rename it. Okay, cool. So get metadata. So we're gonna copy this, paste it over here, and instead of returning get IDs, we're gonna return .borrow NFT of a certain ID. So instead of, we also pass in an ID here of a certain NFT we want to read about. Okay, and we're gonna return a reference to BCBs.nft, right? So because we redeployed the contract that no NFTs exist right now, let's go through the whole process once more. Let's set up a collection for account 1. Let's mint an NFT signed by account 3. We'll call it Ricardo to account 1. Okay. Send it. Boom. We did it. Let's go to our get IDs from account 1. We can see that we minted an NFT with ID 2. So if we go to get metadata, we'll leave account 1 and we're going to type in ID 2. And if we clear this and execute, we should get it's a resource. And here are the fields. The ID value is 2, right? And the name is Ricardo. Woohoo! Yes, we did it. Is there anything else we have to do? We did it. That's it. We did it. Yes. Yay. Okay, one last thing, I promise. Okay, what if there's a problem now, right? We're not going to dive into this topic too much, and we're probably going to talk much more about this in the advanced cadence course. But what we're going to do is talk about what might be a potential problem with this admin, right? Because right now, the only person that can have the admin ever is the contract that we deployed to. So there's two problems with this. One, if you work on a team, let's say the Go2Goats team, only one of them is going to have this admin, right? Not the whole team. And two, what happens if for some random reason they lost the private keys to this contract? Then they would no longer be ever be able to mint an NFT again. So the question now becomes, how can we give admins to other people? And the answer is we can define a public function create admin inside of the admin itself to make new admins. So we can return create admin like that. So can contracts have multiple owners? No. So contracts can only have one owners, because remember back to what was it? This lesson? Remember, in the account, it lives contract code. So contracts belong to one account, not multiple. So that's why we want to make it a function in here called create admin inside the admin so that admins can create more admins. And so then what you can do is inside of a transaction, you can, the admin here can sign a transaction to borrow the admin, create a new admin, and then give someone else the admin. But I know that's confusing, but what is the problem with that one? What's the problem with that solution? Think about who has to sign that transaction, right? We want an admin to sign the transaction, right? Create a new admin and then deposit that admin to someone else's storage. What's the problem with that? And I'll show you an example. So like, um, so think about this problem conceptually, because what are we going to need in this prepare here, right? Because we need the admin to sign the transaction to create a new admin, and then the second part is we need to put that new admin resource in a recipient storage. So the problem is with this one right here. Exactly, Raven. We would need to create a collection. The reason for that is because think about what this means, right? We need to put a new admin resource in the recipient storage. How do you do that? You can't access their storage, right? The only way to save something to storage is to have the auth account. So we need two signers. We need the current admin and then the receiving admin. Because this admin will borrow their current admin, create a new resource, and then the receiving admin will have to save it to their storage. But this is sort of a problem because, multiple signers on a transaction is very rare and quite hard to do actually on Flow. So the solution to that is you have to make an admin collection and then make that collection publicly depositable and then have this admin deposit into the receiving admin, right? You put like the recipient up here into the receiving admin's admin collection. So it's a very difficult process, and I'm not going to dive into the exact solution for this, but I just want to get you guys thinking about what are some of the problems around this. So Fodder says, wait, so how do people trade NFTs to another wallet on Flow? The receiver would need to have a collection. You're exactly right, Fodder, and that's what we talked about today, where, the person receiving the collection has to have a collection set up. And that's why, for example, when you go to Goats or you go to Basic Beast or you go to any NFT projects on Flow, they always tell you you have to have a NFT collection set up in your Blockdo wallet or whatever wallet you're using. So, and the reason they're saying that is because in order for them to deposit to you, you have to have that collection set up. So that's one of the pain points of Flow, but it's also nice because, you do truly own your NFTs on Flow. Isn't it easier to make the NFTs a key? What do you mean by that, Raven? Oh, we actually have quite a lot of people. Also, feel free to keep asking questions because we're done with the content. We made it. Oh my god, you're right. Hold on one sec. I always do this. How do I always do this? And I say that same line every time too. Hold on one second. Let me create this float, everybody. Also, who liked the animated one? The Go with the Flow giveaway? That was cool, right? I'm currently making it right now. HTTPS /MD. Right, let me put it here. Workshop number 6. All right. Workshop number 6. We're gonna add this to the group of Emerald Academy. Use file. Always pull that off screen in case I have any stupid files over here. Okay. We're gonna make it non-tradable. How many people are in here? Like 30 something. So there's no way there's more than like 50 that claim this. Time limit, we'll give people till tomorrow. Claim it. Anyone can claim free, and I'm also just gonna put Happy Friday. Woohoo! All right. Trading. This wave is so smooth animated. I know, right? Oh, no password. Oh, I forgot to put a password. That's all right. Whatever. No password. I mean, everyone here is gonna have pretty much access to this anyway. So, don't forget. Okay. So about creating collection, we don't have to do that on Dapper. So on Dapper, okay, Dapper is an interesting one because on Dapper, first of all, the Dapper wallet is completely centralized because you log in with email and password. So they have a database somewhere, and they're probably like when they create your Dapper wallet account, they're probably automatically adding all those collections for you because it's so centralized. Um, that's probably why. What if someone sent an NFT to another person's account, but they made a typo in the collection name? Um, so that wouldn't be possible, fodder, because the collection names are types on Flow, and you can't mess up the type, or else the transaction would fail. So the collection name would have to be the right one, or else it would fail. He trolled Loki. That's cool. Yeah, that's cool. Animated is good. Be cool. Okay, cool. Yeah. So the event's great, everybody. Oh, we already got six claimed. Nice. I'm claiming mine. Heck yeah. Who got 0? Oh yeah, I forgot to drop the link. Let me drop the link. Sorry about that. Here's the link, everybody. Who got 0? Let's check. I'm actually really curious to see. All right, let's check. Bam. Did Bam get it? Oh, I know. Yeah, I know that address. I know that address. I know that. Yep. Bam. Nice. Also, if any of you noticed, when you use the /resolve or /identify commands now, I made them so that they're ephemeral, which means that they only display for you. So that's just to prevent spam. Calico, I know you're going to be so happy about that. So there's no more spam. But in addition, you'll notice that I also changed address to block to address because in the next week or two, we're going to support Lilyco. So you're going to be able to display Lilyco while it's in Discord as well. And you're also going to be able to add floats to Lilyco wallet and create your own Lilyco Emerald ID. So in about a week's time, we'll probably talk about this in the next Academy session. But on the Emerald ID page, you'll see Lilyco is actually coming soon. So that'll be added probably in the next week. And yeah, you'll be able to do it with floats too. Can floats support non-custodial wallets? Yeah, so floats is going to support Lilyco, which is non-custodial. Yep. The answer is yes for that one. All right, I'm going to end the stream there just because we're done with today's lesson. But if you're watching this on YouTube,